Okay, so let's look at both of these. So first, we wish to test the claim at a significance level of alpha equal 0.001, and we have a left-tailed test, which is good, left-tailed test. We tell that by looking at the less than, um, are usually the easiest, but we're given our data instead of being given our mean and our standard deviation. So let's go ahead and copy this data over to Excel so we can find the mean and the standard deviation quite quickly. Um, um, Actually, let me do that again because I think I hit the wrong thing. This won't copy. All right, and I think I have Excel open, so I'll just do a blank worksheet there. And I'm not sure how many there were, so I'm just going to make it a little bit bigger as I paste. Yeah, there were a little bit less than what I made it. Okay, so there's all my data. Let's go ahead and get the mean. So equal, average, and all I need to do is highlight this and close it and hit enter, and there's my mean. Let's get the standard deviation. Oop, don't want to highlight it yet. Get the standard deviation in the same way, equal, standdev.s, and now I'll highlight all of those and close it. And there's my standard deviation. Okay, so we've got that. All right, so now that we've got that, let's go and let's find our, I think it asks for the critical value first. Yes, okay. So our alpha is a 0.001. This is a left-tailed test. So if I kind of draw that on here, well, that's a really bad drawing of a normal curve, but you get the idea. Um, that means that over here on this left-hand side, I want 0.001 in that area underneath, and I drew it so poorly I can't really put the 0.001 under here. But we need to look up 0.001 and see what that critical value is. So let's go ahead back to where I was. I've got a lot of windows open, so let's see if I can find which one it was again. Um, Oh, I see. I'm still in draw and it doesn't want to let me go back. All right. I don't think that was the right Excel sheet. Let's see. This was it. Okay. So equal. We're going to do norm dot. Now here's where I need to be careful. This is a small sample. So we need to use our t distribution. So t dot inv 0.00, was it 005? 001. 001. Let me just type it again. 0.001. And then we have 14 items here. So our degrees of freedom is 14 minus 1, or 13. And there is my critical value, -3. Now I'm going to write that down before I go to the other field. I'm not sure what we had to round to, so let's go back over here. Round 3 decimal places. So we would use -3.852. So let me use my draw feature. Well, all right, now our test statistic is still the same. It's just that probably you had trouble figuring out what to do about your standard deviation and your mean. So let's just do that here. It's a t instead of a z since this is small. And we want our sample standard deviation. So let me go back for a second. Oh, I got to get rid of my draw again. So I'll write these down so we can go back to that and do it. So our mean was 65.02143. Our standard deviation was 8.601894. Okay, now let's go back. All right, so our test statistic is a t instead of a z. but it really doesn't change what our computation. We're going to do our mean of 65.02. I apologize for my almost first grader like writing with my stylus, or not my stylus, but my mouse. And we want to subtract 68.6. And then on the bottom, our standard deviation was 8.601. 894. And I want to divide that by the square root of our sample size, and there was 14 in our sample. And make sure that 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. Okay, so let's do that calculation, and that will give us our test statistics. So on the top, 65.02143 minus 68.6 is going to give me negative 3.57857, and I know my 8 looks like a 0 there. And then let's do the bottom of the fraction. 8.60189 divided by the square root of 14 ends up being 2.295. Oh, I don't know why it does that. Let me see if I can make it go back. Oh, this is just annoying. That is just a problem with the program for sure. There it goes. Okay. Okay, so I don't know why it does that. There's 2 point. Oh, it's doing it again. Oh, clearly they have not worked out all the kinks in this program. Two point 29895. All right. Again, I apologize for my slow first grader like writing there with my mouse, but we can get to our answer, which is negative 1.5661. Assuming I didn't enter anything in my calculator incorrectly. Let's see, we want to report that to 3 decimal places, so negative 1.557. Now, a while ago, it's erased my critical value, but my critical value was negative 3.852. And so this is definitely not to the left, and it would need to be the left, since remember that our tail, our left-tailed test, this was negative 3.852, and negative 1.557 is somewhere over here to the right of that, and our critical region is this left-hand region. So it would not be in the critical region. You answered the right thing there. And so we would not be able to reject the null hypothesis. We would fail to reject the null hypothesis. So there wouldn't be enough evidence to support our alternate hypothesis. So hopefully, I think it's the t-test and so forth that is, and I clearly need to turn or plug up my computer. So I'm betting on number 7 here, that you just used the the wrong value here when you looked things up. So let's notice our sample size is 10. So we should be using the t statistic when we're looking things up. So this is a right-tailed test since we have a greater than, which means, and I think you're doing the right thing when you're and subtracting from 1 as you should, because of course since it's a right-tailed test, that means our 0.02 is over here. And when we look things up, of course, it always gives us what's on the left side. So, or we have to look up what's on the left side. So really 0.98 is what's over here on the left. And from what you've got here, it looks to me like you are looking things up correctly, just perhaps using the wrong test information. So since this is a small sample size, we need to use our t-test. So let's go ahead and look up 0.98 with a degrees of freedom of 10 minus 1, so 9 degrees of freedom. All right, so if I go back here to Excel, I'll have to get out of drawing. 0.98 equal t dot inb 0.98 with 9 degrees of freedom is 2.398. And of course, if we go back to the problem, that is the value that you needed. Okay, so you were just using, probably my guess is you used the z statistic instead of using your t statistic to look things up. And hopefully that will help you.